Hey guys, this is 18.3, Hydrogen Ions and pH. When you finish watching today's video, you should be able to explain what pH and pOH are. You should be able to relate pH and pOH to the ion product concentration for water, and you should be able to calculate pH and pOH for different aqueous solutions. Let's start with figuring out what the ion product constant for water is. This is going to be abbreviated as Kw, and it's going to show you the value of the equilibrium constant expression for the self-ionization of water. Now we know when we write a K value, we're going to have products over reactants, so let's look at what the equation that gets us this K is. The illustration at the bottom of the slide is actually showing it. It's going to have two water molecules combining to form a hydronium ion that's positive and a negative hydroxide ion. The way they did that is one of the hydrogens left the second water and joined up with the first water. Now remember, when we write a KW, we always go products over reactants. And so our products would be the molar concentrations of the hydronium, which could also be substituted out as just being written as hydrogen, and then that's going to be multiplied by the molar concentration for the hydroxide. Now, this is all going to be over the concentration of the reactants, but in this case, the reactants are both liquid water, and we never include liquids or solids in our K values because they're just going to be pretty much just you put it in as a 1 because it's a constant. So if you have this over 1, you can simplify that equation by just writing Kw equals the bracket H plus times the bracket OH negative. And so that is how we write our KWs. The important part when solving these problems is that you have to remember that the value for Kw is always 1.0 times 10 to the negative 14. That is a value I expect you to memorize, and that way you can use it to figure out the unknown variable. So they're going to give you either the concentration for your hydrogen or the concentration for your hydroxide, and you'll have to solve for the unknown. Let's do an example problem with this. The hydroxide ion concentration in a detergent solution is 1.0 times 10 to the negative 3 molar. What is the hydrogen molar concentration in the detergent solution? Is the solution more acidic or more basic? So the first thing you want to do when you think of this equation is write down the equation that we're going to be using, which is Kw equals bracket H plus times bracket OH negative. Then you're going to plug in the values that you know. And since you had to memorize the Kw, you're going to put that in as 1.0 times 10 to the negative 14. And then notice that they gave us the hydroxide ion concentration. So we're going to plug in the 1.0 times 10 to the negative 3 where the OH is. Now that you have this set up this way, it's pretty easy to see that to solve for the H plus, you're going to have to divide both sides by the 1.0 to the negative 10 to the negative 3. Notice when you divide this off, the side that has the negative 14, remember when you're dividing in scientific notation, you go the coefficients, and you just divide them like normal, so you're going to go 1.0 divided by 1.0, and that's going to give you 1. Then you're going to subtract your exponents. Remember, when we divide, we subtract the exponents. So we're going to type in negative 14 minus negative 3. And remember, when you subtract a negative, you're really adding it. So we're going to end up with 1.0 times 10 to the negative 11. After that, you have to answer the last part of the question, which says, is the solution more acidic or more basic? If you have a solution where there's more hydrogen, you're going to have an acidic solution. Remember that chart that showed you the hydrogen ions, if there's more of them, it's acidic. If you have more OH, then it's going to be basic. Notice in this case, because it's 1.0 times 10 to the negative 11 for your hydrogen, and then it's 1.0 times 10 to the negative 3 for your OH, the OH is actually larger than your H. So that means the solution is more basic. Now we're going to get into explaining what pH and pOH are. pH is the negative logarithm of the hydrogen ion concentration, and this is always going to be the molar concentration of your hydrogen. So you just are going to type in negative log, and then you're going to type in your concentration for your hydrogen. When you use the pH scale, acids will always be smaller, so they're going to be from 0 to 6.9. 7 is neutral, so it's right in the middle, and then when you have 7.1 to 14, that's going to be considered a basic item on the pH scale. This is important because it's different with the pOH scale. The pOH scale is actually the negative logarithm of the hydroxide ion. So these are the OH concentration. So you just type in negative log and then you type in your molar concentration of OH negative. On this scale, it's reverse. Because we're looking at and focusing on our hydroxide, that's what's going to be the lower number. So on the pOH scale, when you have 0 to 6.9, that's considered a base. 7 is still neutral, but then 7.1 to 14 is considered an acid. The important part here is that you realize which scale you're looking at because you don't want to confuse if something is an acid or a base on these scales. When we do our calculations, it's important to remember that the pH plus the pOH is equal to 14, and it's always equal to 14. So they might give you a pH and then ask for the pOH value, and you'd have to subtract that value from 14 to find your pOH reading. Let's practice a few problems with pH and pOH. Calculate the pH of a solution that has a concentration of the hydrogen ions being 1.0 times 10 to the negative 8 molar at 298 Kelvin. Is the solution acidic or basic? So we first want to remember our equation, and to find pH we need the negative log of the molar concentration of H. Well, they gave us that. It's 1.0 times 10 to the negative 8. So you're going to type in your calculator negative log 1.0 times 10 to the negative 8. That's going to give you a value of 8.0. Then you're going to think about your pH scale. And remember, this is the pH scale, so when we have 7.1 to 14, that's basic on the pH scale. Since we have 8 as our final answer, the solution that we're dealing with is basic. Here's another one. Calculate the pOH of a solution that has a concentration of H plus 3.2 times 10 to the negative 3 molar at 298 Kelvin. Is the solution acidic or basic? So here we actually are given a multi-step problem. Notice that they want the pOH, but they gave you the concentration of the pH. So it would be wrong to type in the negative log of 3.0 times 10 to the 3 and expect that to be your pH or pOH value, because that is not your pOH value. That would be your pH value. So we're going to do this with two steps. We're going to realize first that we can find our pOH value by adding our pH and our pOH, and that will be 14. So all we have to do is find what the pH scale is and then subtract it from this problem. So let's type in pH equals negative log times 3.2 times 10 to the negative 3. That's going to be a value of 2.5. So then you just have to use our 2.5 on the pH, pH plus pOH equals 14. And so when you see this, you subtract 2.5 from both sides, and the pOH is going to be 11.5. Now remember, you're looking at the pOH scale. So if you have pOH scale 7.1 to 14, that's acidic. So this solution is acidic. Here's a practice problem for you. I want you to find a vinegar solution has hydrogen ion concentration of 4.0 times 10 to the negative 4 molar. You're going to find out what the pH is. Now that you've finished watching today's video, you should be able to explain what pH and pOH are. You should be able to relate pH and pOH to the Kw, and then you should be able to calculate pH and pOH from different aqueous solutions.